Recording. All right. We are recording. For anyone not here, this could be for who's not here. Demetrius, Bebeck, Daisy, C1, and then anybody else that I'm missing. So let me share my screen. And all right, let's get going. So if you guys remember Tuesday, if you were here, we learned about experimental protocols in like plant-based experiments. What we got is we got materials. If you remember, it was like tomato plants, 10 pots, bag of soil, water, if something like that. Then it gave us a procedure, so what to do. So, fill the pots with soil, put a seed in the pots, put earthworms in some, put water in all, and stuff like that. And then it would just ask us questions. Oh, and sometimes there would be a chart. Like, if you remember our chart, our data chart was something like, what happened with the pots with no earthworms and what happened to the pot with earthworms. So that's this whole protocol. It's basically just like your layout of an experiment, all right? So to do an experiment, you need your materials, you need to know what you're gonna do, in what order, and at the end, you need your little data chart to figure out what happened in your experiment. So we're still kind of going on that a little. We are adding something called diffusion in here today. And so we're going to talk about that right up here. The instructions for how to carry out a science experiment is called an experimental protocol. If we remember that, it often includes a list of materials, it includes a procedure, and then some include a data table for recording the experiments. All right. Now, the experimental protocol below is for an experiment testing how quickly food coloring mixes with water. When food coloring is added to water, the particles of food coloring will spread throughout the water in a process called diffusion. All right? So, again, when food coloring is added to water, the particles of food coloring will spread throughout the water in a process called diffusion. All right? Oh my gosh, whoa. What is happening? How did I do that? Oh my gosh, I don't know how to stop. Okay, figured it out. Sorry. All right, so guys, we have materials. We have two identical, keyword identical, glass beakers. We have hot water and cold water. If you remember Tuesday, remember it simply just said water. And I told you that in an experiment, when you're doing science, if like it wants you to do hot or cold, it'll tell you because that's important in science. And so here it's telling us we do this time have hot and cold water. We have blue food coloring and then 2 stopwatches. All right. How we do this, our procedure is we pour 200 milliliters of hot water into one beaker, 200 milliliters of cold water in the other. You put 3 drops of food coloring into each of them. Measure how long it takes the food coloring to spread evenly throughout the water in each beaker. Record the times in the data table. Clean the beakers. Repeat steps 1 through 6 2 more times. All right, and then we have our data table here. So we're testing the diffusion of the blue food coloring into our water with a beaker of hot and a beaker of cold. All right, so which materials are required for this experiment? Or select all that apply. All right, again, please raise your hand if you think you know. If you have no microphone access, you are allowed to use the chat. The chat should only be used for science or class-related things. So, since class has officially started, just as a reminder, no more using the chat for things that are not science or class-related. As long as it's name appropriate, I will call you by the name that I see. So for the person whose name is just a period, I'll call on you because I really don't know who is who except for Chantel and Deshawn and Sabrina.
Food coloring, hot water, and cold water.
All right. Food coloring, hot water, and cold water. All right. And we can double check him. We do have food coloring. All right. And then we do have hot water and cold water. This is beakers of different sizes. If you remember, I said keyword was identical, which means they're the same. They're not different. 4 stopwatches. Nope. They only wanted 2. So good job, honest. Awesome. All right. What to look for. All right, the picture below show what the food coloring and water will look like at the beginning and end of the experiment. You will know the food coloring has spread evenly throughout the water when the color is uniform or the same throughout, meaning like just it's all blue water now, instead of that first picture where it looks very wispy and you know to be honest, it looks very cool to me. It's just very and super pretty. Um, so this is food coloring diffusing in water, and then food coloring spread evenly throughout. All right. Diffusing means that the food coloring is separating from itself. All right. It is separating from itself. So it's not dissolving because dissolving means it disappears, but it's diffusing, it's separating from itself because if you have the food coloring in a bottle, it's all food coloring. It's all together. But the moment you put it in water, the food coloring starts to separate and join with the water. So it's no longer just food coloring. So it diffuses. All right. It diffuses from itself. Um, Fun fact. All right, here we go. Next one. And guys, this is the same experiment, it seems. So we're still identical glass beakers, cold, hot water, blue food coloring, 2 stopwatches. And then the same thing. One of hot, one of cold, food coloring, stir, record, clean, repeat. All right. So how much water will each beaker contain? All right. If you go back to our procedure, it tells us the answer. Again, I would love to see raised hands. Would love to see raised hands. And if your microphone genuinely does not work, you may use the chat only for school. Reham, I saw yours first. And I know Reham's microphone is weird sometimes, so I will check the chat. Or not. I'm just mad that it doesn't. There we go. I don't know why that was so hard. Okay, Reham, feel free to type in your answer. Or say your answer. I just know that you typically type. Yeah, okay, cool. Yep, she is right. It is indeed 200. That's what it says in our procedure. All right, now how many drops of food coloring will go into each? How many drops of food color? Come back. It really doesn't do it unless it's down here. I said it, I guess it didn't work. Oh no, yeah, I couldn't hear you. I'm sorry. Um, sorry. So now how many drops of food coloring? Samriti. Samriti? 3. Boom. Yes. Why does it do this to me? That's so weird. If I move this down and then hit chat, it pops up. But if I, whatever. It's just so weird to me. But okay. Okay, boom. Right, now I'm gonna scroll down. How many times will step 1 through 6 be completed? So how many times are we doing step 1 through 6? Again, it is in our procedure. And I would love to see some hands from students who have not participated yet. So currently that's just Chantel and Deshawn. C1 was here and then I don't see him anymore. Um, right? Chantal Deshawn. Remember, you do have to participate at least once to be counted present today. Because as I've learned, as we've all learned this past week, some of us like to pretend we're on Zoom and go to sleep and not get called on for 45 minutes. And if that happened, I did mark you absent. And that has happened twice this week. And if your parents are upset, I would be more than happy to explain to them the rules of my classroom is to be fully awake and here, whether you are participating or not. You are not allowed to just Zoom and go to sleep. Just as a reminder. So, Chantel or Deshawn, it would be wonderful if one of you participated. All right, and that's okay. Boys, you're good. Thank you for letting me know. Okie doke. Well, then I will call on someone who is here. Just remember, Chantel and Deshawn, you gotta participate before we're done, or I'm marking you absent today. Okay. Reham. 12. Oh, that's what I was looking at. Ah, see, guys, Reham is very close. This question's trying to trick her, though, just so we're aware. Oh, no, she's right. How many times will it be completed? No. Okay, watch. Okay, let's just double check because they're wording it very tricky. Okay, so this is the procedure. We did it once, and then it wants us to do it again 2 more times, which is 3. So we have 3 trials here as well. So we have to be very careful with how they're wording it. So they're trying to trick us, just so everyone is aware. How many times will steps 1 through 3 be completed? 3 times. If it was how many times will it be repeated, it would be 2. So now it's correct. Does that make sense? It was really trying to trick us. So, which is not fair to anybody. It's 1 through 6, not 3. No, it wasn't saying, I see what you're saying. It wanted to know how many times we were doing all of these steps. And if we look at our data table, we're doing it 3 times. The first time, then we clean the beaker and do it 2 more times and record it. So that's why the answer was 3. I know that sounds super confusing. Also, same. Okay. All right, what do trial 1, 2, and 3 in the data table refer to? What do they refer to? Do they refer to the first, second, and third beakers used? The first, second, and third times that step 1 through 6 are completed? Or the hot water, cold water, and warm water in the experiment? What 3 things are these represent? What 3 things are the trials representing? I would love some raised hands. It says 3 people raised their hand, but I only see 2. There we go, Chantel.
I think it's the okay.
You got this. Remember, you can always, I'll scroll up a little, and I'll move this. But you can always look at our procedure, which will help too. You can always look up here to
Can I
figure out.
say the one that should be taken away?
Sure, yeah, that works. Go ahead. Which one should be taken away?
Like, can you scroll down a
Oh,
little bit? I don't see the third one.
that's okay. Yep. So which one
Thank
should
you.
be taken away?
The first one.
Yes. Good. The first one, guys, it talks about the first, second, and third beaker. We only got 2 beakers. Remember? One with cold, one with hot. So it's not the first one. So Chantel, you are correct. Chantel, do you want to keep going or do you want to give it to someone else?
I'll keep going.
Okay. So that means there's a 50-50 chance, Chantel. One of these is right and one of these is wrong. All right? But based on what we just learned about there not being 3 beakers, we should, if we read carefully, we should know which one of these is wrong. So read them carefully and remember, there is not 3. So read them carefully and remember, there is not 3. We just did that. So which one of these talks about 3 things that we know we don't have?
Oh, the last one?
Yeah. So we have hot water, sorry, we have hot water and cold water. It doesn't ever say we have warm water. It never said that. So there's no way it's this one. So Chantel, it is the second one. Good job. So guys, what Chantel did works just as well. She might have not known what the answer was, but she knew what the answer was not. And that counts as participating too. Okay, you guys can do that as well. All right. So good job, Chantel. That was fantastic. All right. All right, guys, still the same. Um, it's still the same experiment, okay? We do have a new question, though. I'm officially back. It is too. Yes, Bebek, it was the second one. And Ayub and Anis, welcome back. Um, Bebek, we are currently we're doing science, and everyone needs to participate at least once. Based on who's here now, it's between you and Deshawn. I need one of you two to participate. Just before this is all over, and then everyone else can participate. So during each trial, which of the following should you do before adding the food coloring? Which one of these do we do before adding the food coloring? If you remember, step 3 is add the food coloring. So what we do before can only be step 2 or 1. Can only be step 2 or 1. Right? Do you see step 2 and 1? I'm going to go back down. Excuse me. All right. So which ones happened before? Observe the mixtures to determine the food coloring has spread evenly. Put 200 millimeters in cold water. Measure 200 millimeters of hot water. Start the stopwatch. Bebek,
3?
you think this one? Okay.
Yeah.
Okay. Measure 200 millimeters of measure 200 millimeters of hot water. Okay. And remember, it says select all that apply. So are there any other ones that could work? Are there any other ones that could work? Or we can do what Chantel did. Are there any ones that we know for sure don't work? I can tell.
Yeah.
So Bebek, which one do you think it is or is not?
Is I think the fourth one?
You're right. It's not that one, because that's like the last thing we do. Okay, so he's right. Let me cross that one off.
And it's not the first one.
Yeah, good job. We can't, before add food coloring, we can't observe food coloring before we added it. That doesn't make any sense, so he's right. So, so can we do this one before we do the food coloring? Can we put 200 millimeters of cold water?
Yes.
Yes. So it possibly can be both of these. All right, this one's worded funny because technically it doesn't tell us to measure 200 millimeters of hot water, but we are measuring 200 millimeters when we pour it in. So I'm pretty sure Bebek is right. Yes, he is right. Okay, I just want to double check because they worded that funny, but Good job, buddy. That was great. All right, so Deshaun, you are up, my friend. All right, this one is for Deshaun only, and then once he has participated, then it is free game for everyone. All right, for the rest of the day. What data are being collected and recorded in the table? So what are we recording in this table up here? The amount of hot water and cold water, the time it takes the food coloring to spread evenly through the water, or the number of drops of food coloring. And Deshaun, you can tell me what it is or what it is not. Oh, is he typing? Come back. Bottom. So the bottom is it is or is not? Not. Good. You're right. It is not. So Deshaun is right. It's not that one. We're not measuring the number of drops because we already said that we're doing 2 for both of them. So there's no point in doing this experiment 3 times if we already know how many drops are going in. So, Deshaun, do you want to keep going or give it to someone else? It's the middle one. Boom. Good job, buddy. Yes, guys, we are testing to see how long it takes to get the food coloring in it. And then the first one, we're not measuring hot and cold water because they're the same, if you remember. So good job. All right. Everyone has officially participated at least once, so now the floor is open to the whole class again. All right, here we go. Which variable are held constant in the experiment? A variable being held constant, that is something in your experiment that stays the same and does not change at all for all 3 trials, okay? Hint, variables that are held constant, it says the hint right there and I totally didn't see it. So what is being held the same the whole time, no matter what? Ayub.
The type of beaker,
Okay.
the temperature of water added to each beaker.
Okay.
Wait, is that like, does that mean like the same temperature for each beaker, or like just because it might be like the same water for each beaker? Because it's not that then.
I don't know.
Okay, I'm just not trust that then.
It's up to you.
You're selling me, Mr. Hugh, I swear.
I
And then the amount of food coloring added to each beaker.
Mm-hmm.
The amount of water in each beaker.
Mm-hmm.
That's it.
That's it?
Yes.
See, he's right. Good job, buddy.
Let's go, baby. I'm so smart. Oh my god.
So guys, he is right. The beaker stayed the same, the drops stayed the same, the whatever the other one was stayed this. Oh, the amount of water stayed the same. The temperatures were different though, if you remember. So one was hot water, one was cold water. So like Vivek is saying, not Vivek, Ayub, what? I mixed you two up. I'm so sorry. Like Ayub was saying, if this question was worded like, it would have said something specific like, did the hot water in one of the beakers stay the same? But it didn't say it like that. It said, did the water stay the same in both? Which is not true, clearly, because the water wasn't the same in both. One was cold, one was hot. So science is very tricky because science is very specific. So always keep that in mind. Like when we eventually take our like quiz and test in this month for science, just know science is a very specific thing. All right. If it gives you like a random general answer, or a random general fact, your answer will also be random in general. Your answer will never be specific unless what they give you specific, okay? So take that as you will. To me, that would make things easier, but I can see how that might be confusing for some, but just keep that in mind. If it was just talking about water and didn't say anything, the answer would have been some general water answer. But since it's specific about hot and cold, the answer would have had to be specific. Okay, next. In this experiment, the temperature of the water is blank. The time it takes for the food coloring to spread in the water is blank. These are independent and dependent variables. We did this, what, 3 weeks ago? I think 2. All right, I wanna, one, just see who remembers, and then I can always review for everyone what this means. I see 2 hands up. Reham, Ayub, do you guys like have your hands up, or did you just never put your hand back down? Ay, ay, ay. Okay, Ayub, I get it. What am I putting, buddy? Or honest.
Okay, Ayub, and then in this experiment, the temperature of the water is a dependent variable, and the time the time it takes the food coloring to spread evenly throughout the water is an independent variable.
Okay, so you think it's this one?
Yes.
Right, you sure?
Yes.
That is not correct. So, and this is why. So, anything in the experiment that is like staying the same, it's the thing you're not changing, that one is going to be the one that is independent. That one, like the water, it's always going to be the same. That's not changing. The time, however, for each experiment can be different. So the time depends on the food coloring in the water and the diffusion. The time is dependent. It's depending on something, you know? Like if I go to the store and the self-checkout's gone, I'm depending on the cashier to check me out, to get all my groceries and everything done. I am depending on them. They're not depending on me. They're they know what they're doing. They have their register, they have the scanning, they have all of that. They are the independent variable. I'm the dependent one. I'm depending on them. So again, in this, the water isn't depending on anything. The water is just the water. It gets to chill and just be water, and we can trust that it'll be water the whole time. But the time will always be different. Even if it's by a second, it'll always be different. So the time was the dependent variable. Does that make sense, everyone? Thumbs up emojis?
It does. Thank you.
Yep, no problem. Okay. I don't see, okay, Chantal, thank you. And thank you, Ayub. Everybody else, do you get that? Because I'm gonna hit go.
Yep.
I'm gonna continue. Okay, Sambriti, thank you. Anybody else? Nobody else? All right, well, I'm gonna keep going. Okay, so same experiment. All right. Which question can we answer in this experiment? We talked about this last week, experimental questions. So based on just all the things we have, what can we do basically, you know? And so 2 of these we can't do. 2 of these we're not going to be able to do. So the first one, does the shape of the container affect how quickly the food coloring spreads? Does the amount of water affect how quickly the food coloring spreads? Does the temperature affect how quickly the food coloring spreads? Sambriti. excuse me, the second one. You think it's that one? Right? Does any, let me check the chat. What does IG mean? IG? I guess. Oh, got it. I didn't know that. I guess. Reham, do you agree or disagree? You agree? Okay. Ayub, do you agree or disagree? Disagree. Interesting. What do you think it is, Ayub? The bottom one. Interesting. So we have 2 students who think the amount of water affects. We have 1 student who thinks the temperature is what's being affected. I think there's 2 answers, and then Reham thinks there's 2 answers. Interesting. So guys, this one's fascinating. I really only feel like I have 3 students participating, so hopefully everyone's at least listening, even if you're confused. Remember, our experimental question can only be answered on what we have. So let's look at these 3 things and see if we have, and see which one we have. So this one is talking about shapes of the container, amount of water, and temperature, meaning our containers need to have different shapes, our containers need to have different water amount, and our containers need to have different temperatures. So let's see which ones we have. All right, we have 2 identical glass beakers, so there's no way it's the first one because they're identical, you know, and the first one says that the beakers are different sizes, so it's not that one. All right, the last one talks about different temperatures, which is true because we do have one that's hot and then one that's cold, so that one can work. There's more people coming. Demetrius is coming in 2 different ways. So we could for sure do that one. And then the middle one talks about amount of water. And the middle one talks about amount of water. So our materials doesn't tell us the amount, but our procedure does. This one is 200 milliliters of hot and 200 milliliters of cold. So our amount is actually the same also. So it cannot be the middle one. The only thing we can answer is the last one, right? Good work. Ayub, a prediction is an informed guess about what might happen. So I think you guys know what a prediction is. A prediction is just like, I think this is going to happen, basically. You guys know that. So sorry, I wasn't checking the chat. What did we say? Why else would they? It might be the last one. The experiment can answer the second and third. A little bit for the second, but mostly the third. Wait, I'm glad we're using the chat to talk about science. That does make me happy. Hi, Demetrius. We're just still doing class. I think we're almost done. How many do we have? Yeah, this one we only have to do 3 questions. So Demetrius, since you just got in, I would love it if you could answer one of these questions. All we're doing is pretty much doing what we did Tuesday. We're given materials, procedure, so an order of what to do, and then it asks us a question based on what we have and the order to do it in. So if you could answer one of these next 3 questions, that would be great. All right, so this is for everyone, but Demetrius, if you think you got it, let me know. It says, how much water will each beaker contain? All right, the answer is in this procedure, by the way. The answer is in the procedure. It is in steps 1, 2, 3, 4, 5, 6, 7, one of those. So, does anyone think they know it? Demetrius, do you think you got it? You can use the chat too if you would like. $200. Good job, buddy. That is correct. It is 200. It says it right here. 200 milliliters. Boom. All right. How many drops of food coloring will go into each? I want to hear from Anis because I know Ayub's the one pressing that button over and over again. So if Anis knows it, I will gladly hear from you two.
Anas has it.
Sure. Anis, what is it?
3.
How many drops will go in all of them?
Yep.
You said 3?
Yeah.
Yes. Good job, buddy. Yep, says it right here. Put 3 drops of food coloring. Boom. All right, and now how many times will the steps 1 through 6 be completed? Not repeated, completed. Okay, again, this was the one that tried to trick us. Completed, not repeated. Who thinks they know? Chat. I do, of course you do. Ayub, what is it, buddy? Yes, it is 3. Good. All right. Next one. What data are being collected? What data is being collected? Shouldn't I say what data is being collected? That's bad English. What data is being collected and recorded in the table? The amount of hot water and cold water in each beaker, the number of drops of food coloring, the time it takes for the food coloring to spread. Let me take a guess. Ayub, would you like to answer this again? Of course. What is it, buddy?
It is. Watch out, Anas. Watch out. It is the bottom one. The time it takes the food coloring to spread evenly throughout the water.
This is correct. It is the time. All right. There we go. All right, guys, last question. We are done for today. I'm pretty sure, unless it like makes us do more, but I'm pretty sure this is the last one. This wants to know which one is the independent variable. IU, would you like redemption on this?
Yes.
All right, IU.
It's the bottom one, a dependent and then an independent. Or yeah. Wait. Did they switch it? I can't tell.
So let's read it and let's see if we can get this going. In this experiment, the temperature of the water.
Oh no. Okay, no. An independent variable for the first one, and then yeah, I think. Wait, why is this one so confusing?
It's okay. It's okay. We're gonna redeem you. We got this. So the temperature of the water and then the time it takes. Which one of those?
The one we're at right now. It has to.
You think it's that one?
Yes.
Why?
Because the temperature of the water, it just stays the same throughout the entire time, and then with the time it takes to do the food coloring thing, it's like, what was it? What? And so I can't explain it in words.
That's okay, but you are right because the temperature is independent. The temperature will stay the temperature for a while before it starts to either cool down or whatever. So the temperature isn't depending on anyone or anything. The temperature's chilling. The temperature's doing its thing. However, the time will depend on the water, on the food coloring, on how you stir it, on everything. So, Ayub, you have officially redeemed yourself. Boom. All right, I'm gonna close this. Yes, okay, we can close that. Screen should stop sharing itself. Boom. All right, I'm gonna